So let's begin. Have you ever dreamed of a snake biting its own tail, only to wake up and realize you've just unraveled the secret of the benzene ring? That's exactly what happened to August Kekulé, the German chemist who thought a vivid dream and discovered the cyclic structure of benzene, a breakthrough that changed the course of organic chemistry forever. Hi, I'm ARG Zania, and I'm here with the presence of my other group mates from Group 5, and today we'll be tackling about the benzene ring. And I would also like to recognize uh, my other group mates, and so I will be reporting alongside with Leo Ortega, Sofia Odevillas, and Kalal Palacio, and we have an audience from my other group mates since this is a recorded group report. We have here Miss Ngoho, Miss Padernal, Miss Monzon, and si Miss Munoz, and our other group mate, Miss Perez, which is not here right now, but she also contributed to our report. And without further ado, let's begin to the next part of our report. So, like the other groups, we'll be tackling these inventions or discovery, the benzene ring, concise history and background. Second, the circumstances to its invention. And third, the contributions to scientific progression. So now, I will give the floor to Leo Ortego to discuss about the concise history and background of the benzene ring. Leo.
Thank you, Ave. Uh, to start, I am Leo Energy Ortego, and I'm here to report about concise history about the benzene rings discovery. The benzene rings discovery began with Michael Faraday identifying bicarbonate of hydrogen in 1825, later named benzene by Elhard Mitscherlich in 1833. In 1865, August Kekulé unveiled its true structure, a six-carbon ring with alternating single and double bonds, after a dream of a snake biting its tail. His breakthrough explained benzene's stability and revolutionized organic chemistry, paving the way for aromatic compounds used in plastics, medicines, pesticides, and dyes. So, this paragraph explains that uh, it was Michael Faraday who first discovered benzene rings, but in 1865, Auguste Kekulé unveiled its true structure. For those who do not know benzene, so I'm gonna explain what is benzene. Benzene is C6H6 if its chemical formula. It is a simplest organic aromatic hydrocarbon and parent compound of numerous important aromatic compounds. Furthermore, benzene is a colorless liquid with a characteristic odor and is primarily used in the production of polystyrene. It is highly toxic and is known carcinogen. Exposure to it may cause leukemia. As a result, there are strict controls on benzene emissions. That will be all for the information about the concise history of benzene ring. And I would like to give the floor to Miss Sofia Odevillas for the circumstances that led to the invention of the benzene ring. Thank you.
Thank you, Leo. Hello, everyone. My name is Sofia Francisco de Villas, and I'll be reporting about the circumstances of the invention of the benzene ring. So the benzene ring was not made or invented, but was discovered, where it all started in the early 1800s, wherein in 1825, an English scientist named Michael Faraday, who was famous for his work in electricity and chemistry, made an exciting discovery. While studying illuminating gas used for lighting homes before electricity, he found a colorless, oily liquid that burned with a bright, smoky flame. He called it benzene, and its formula was C6H6 or carbon 6, hydrogen 6, which was discussed by Leo. But here's the strange part. The benzene didn't match any known structure in chemistry at that time, and a few years later, Eilhard Mitscherlich, another scientist, made benzene by heating benzoic acid, a natural acid found in some plants, with lime, a white powder made from limestone. Soon after, scientists discovered that coal tar, a thick black liquid from coal, was another rich source of benzene. Next, please. By the mid 1800s, chemists already knew benzene's formula, which was C6H6, but they were completely puzzled by its structure. The same problem in the early 1800s. Normally, compound with that formula should be very reactive, but benzene was surprisingly stable and became the biggest mysteries in chemistry. In 1861, a scientist named Joseph Loschmidt suggested that benzene's atoms might form a ring, meaning that the atoms are considered or connected in a circle. Chemists also noticed that benzene also made a few kinds of isomers or different forms of the same compound. That clue told them that the atoms must be arranged symmetrically or evenly around the ring. This strange behavior made benzene so fascinating that scientists all over around the world started studying it. Next, please. In 1865, a German chemist named Frederick August Kekulé finally proposed a solution. He said that benzene is made of six carbon atoms forming hexagonal ring with alternating single and double bonds. Kekules later told a famous story where he said he dreamed of a snake biting its own tail, forming a circle, and that dream gave him the idea of benzene's ring shape. Some people think that it wasn't a real dream, but it was a clever way to explain how he came up with the idea. He also suggested that the double bonds constantly move or switch places, or some say that it doesn't stay in one spot, making all the bonds equal. So for those people who forgot what double bonds means, a double bond is a two atoms share two pairs of electrons instead of just one. And this idea perfectly explained why benzene was so stable and balanced. Next, please. So as time went on, new tools helped scientists see what was really happening inside benzene. They used X-ray diffraction, which lets us see how atoms are arranged, and spectroscopy, which studies how light interacts with matter. These experiments prove that all carbon-to-carbon bonds in benzene are the same length, about 1.39 angstroms. That means that the electrons are shared equally around the ring. Thanks to quantum chemistry, one of the branches of science, scientists learned that benzene's six pi electrons move freely around the ring, creating resonance-stabilized aromatic system, which basically a fancy way to say that the electrons are spread out evenly, keeping the molecules super stable. This concept was further explained by Eric Huckel, who discovered Huckel rule to describe aromatic stability. This discovery confirmed Huckel's ideas and helped form the modern concept of aromaticity, which explains why benzene and many similar compounds are so stable. So at this juncture, now that we know how the benzene ring was discovered and proven, we will proceed to the last section of our report, which will be discussed by Kalel Palacio.
Thank you, Sophia. I'm Khalil Jadon Palacion, and today I'll be talking about the benzene rings contributions to scientific progression. The benzene ring concept is the foundation for aromatic chemistry, which is essential in organic chemistry, pharmaceuticals, and material science. The structure has paved for the way for the concept of aromaticity and resonance. Because of this, we have developed an understanding to the influence of benzene ring, which has also further influenced the broader field of aromatic chemistry and organic synthesis methodologies. Next, please. August Kekulé's discovery and structural explanation has allowed scientists to understand and create many other aromatic compounds. Due to this, the benzene ring made it a key building block for producing synthetic dyes, plastics, pharmaceuticals, pesticides, and polymers. It has contributed to petrochemical industry as an intermediate for making chemicals like ethyl benzene, cumin, and cyclohexane. Overall, the benzene's ring discovery advanced both scientific understanding and industrial development, which has shaped the modern chemistry and technology. Next, please. So let us shape our understanding of benzene structure, which has led to several key advancements. First off, Kekulé's ring model introduced the concept of aromaticity and resonance, which also became central to understanding molecular stability and reactivity. Benzene's structure became the template for countless synthetic products, emphasizing the industrial and pharmaceutical impact of the benzene ring. Benzene has also served as a raw material for producing ethylbenzene, cumin, and cyclohexane. And to top it all off, there was a scientific advancement by Kekulé's discovery of the benzene ring. This leads to chemists to explore more about molecular geometry, bond hybridization, and electron distribution. And that is all for the contributions to scientific progression chapter. I will be now giving the mic to Avi Andre to conclude our reporting.
Thank you, Khalil. So that was the three sections of our report, and now I'll proceed to the conclusion. So to read, Thakkal's discovery changed theoretical chemistry by introducing structural formulas and the idea of three-dimensional molecular shapes. This transformed how chemists understand and predict chemical behavior and led to the establishment of structural organic chemistry. So in other words, or in simpler terms, um, the discovery of the Benzene ring wasn't just the discovery of random shapes and structures of molecules. So it wasn't just stuck together and represented something, but it determined how molecules behave. And it was a basis of understanding of how molecules work in the field of science. So that's how this discovery made it pivotal for the future discoveries later on. So that's one significance of the benzene ring discovery. So, in a nutshell, so that we can remember all what has been discussed by our report. So first, benzene was discovered by Michael Faraday in 1825 and named by Eilard Mitscherlich in 1833. Next, in 1865, August Kekulé revealed its ring structure of six carbon atoms with alternating double bonds, later explained by Eric Huckel's concept of aromaticity. So this was when he dreamed of a vivid description of the ring. And lastly, this discovery became the foundation of aromatic chemistry, leading to major advancements in organic synthesis, pharmaceuticals, and industrial chemistry. So this was explained by our group member Kala. So this at this juncture, we have completed our report, and I would like to thank you all for listening and rendering and investing your time into our report. So I would like to also acknowledge the workmanship and cooperation of our group members who contributed for the success of our report. So these are the roles and their names of our group members. So we have Miss Monzon, Miss Munoz, Miss Mojo, Miss Odevillas, Mr. Ortego, Miss Padernal, Mr. Palacio, Miss Perez, and me, Tizania. So thank you so much for rendering your time, guys. And the other members who weren't reporters also rendered their time as our audience for our reporting this night since it's recorded since we were not able to report earlier due to some unexpected circumstance. So thank you so much, and I hope you all understood our report. Once again, this is Ava and G. Tizania signing off, and the rest of the group. Bye.